I welcome on behalf of National Agricultural Higher Education Project established at Vasantrao Naik Marathwada Agriculture University, respected Honorable Vice Chancellor Dr. Indramani sir, respected Dean and Director of Instructions Dr. D.N. Gokhale sir, respected all senior dignitaries, and also respected all dignitaries from University of Putra. Today I am here to present uh, on digital technologies uh, in precision farming. Specifically, the digital technologies for digital farming solutions. We are aiming to establish this activity between University of Putra and Vasantrao Naik Marathwada Agriculture University. Today I am here to deliver this presentation as per the available resources and those strengthening laboratories which we are having here with in our university, that is going to be a help us during our collaboration activities. I'm really thankful on this occasion to to pay my gratitudes and thanks to Indian Council of Agriculture Research, specifically the National Director Honorable R.C. Agrawal sir, National Coordinator Anuradha Agrawal madam, our Honorable Vice Chancellor, who is always encouraging and energizing us to get this all digital technology activity implement at our university level to make a global center, Dr. Indramani sir, Dr. D.N. Gokhale sir, who is academic and always supporting us in every activity for delivering those all digital technologies from this university. In fact, all NAGP team members, those who are working there, they belongs to different discipline. So today I'm going to present on this topic. I'll just share my presentation here. I hope everybody is able to see this presentation. Digital technologies in precision agriculture farming. So the project is titled as excellence of Center of Excellence for Digital Farming Solutions for Enhancing Productivity by Robots, Drones, and AGVs. This project, we have a specific thematic areas to cover up and get the digital technology applications for the farmers' problems, and specifically the researcher students who are aiming to make the advanced digital technology learn by developing their skills, and those things which are aiming to make our project objectivities for the enhancement of the productivity as well. We are having three divisions. We have specifically made these three divisions: agri-bot, agri-drone, and agri-AGV, based on the four portfolios which are in participating the interdisciplinary faculty. So the climate-based decision knowledge support center, seedling processing nursery automation center, smart portable machinery center, food processing automation center, and instrumentation cell. We are making this club of a different interdisciplinary faculty scientists to make their problems sort and get the solution out by use of the digital technology. In this, I would like to say this is the new and most prestigious thing from our NAHEP center, which is, we call it as a DFSRDA. This is Digital Farming Solutions by Robots, Drones, and AGV. We are classifying the three divisions of applicant devices as agri-bot, agri-drone, agri-AGV. And the portfolios, as I mentioned, CDKS, SSPN, FPA, SPM, and instrumentation cell. So we are about to complete our activities about the establishment, and we are now aiming to participate with the different international, national level institutional participation for getting new technologies to adopt and get the mutual collaboration activity for the digital farming solutions. We are having Indian Institute of Technology, Kharagpur Indian Institute of Technology, Bombay with us as a knowledge partner, and they are training they are giving the training to our researcher students as well as faculty students in related thematic areas, also getting them involved in the participation of problems and solutions in farming in farming automation. So we are having the AgriBoat as a one of the important device which is aiming to make the field automation. So here we have a Jackal and Husky robots in which we can use these robots for different harvesting operations, weeding operations, seed sowing operations, grafting operations, pest detection, pest control operations, then plant fruit population counter and biomass and yield prediction. With this, the device which is automated and used by the researcher students, they need some kinds of attachments, they need some kinds of components to be designed and then attached to the device as a robot which is field rover. So for that we have a 3D printer system which is helping the students to print out the physical components as on when they require to use it on the robotic system. No doubt we have the applications as well as the researcher studies by use of the different cameras, different sensors, which will be helping the students to analyze the field problems and get their solution out. We are having those all robotic systems at VNMKV center, as well as now as a present myself and Professor Dakpore, we are here in United States of America. We are working in the University of Florida, and we are also experiencing the field robots in blackberry and blueberry plots. So you'll see that the applications that we are going to run it in the system, that has to be the aim which is giving you the exact output. So the locational problems by use of the Husky robot that we are exercising and experimenting in the field to get the knowledge of what is the exact situation of the crop for their different pest and their pest control management. So robot and Husky, these two devices as well, we are working with them, and also we have designed new robot, that is cotton picking robot. So this system is going to help us for the students who are really aiming to make their agricultural robot applications. We are associated with the various robot clubs at a national level and international level. Students will compete and get their applications for the attending different kinds of problems. So I am making the introduction of this robotic lab, which is very much prestigious and for the researcher students who can avail this facility. Then agri drone is that is a nowadays, as aerial robotics is very much popular, and government of India is also encouraging for the drone applications in agriculture, specifically image sensing and the spraying operations. So for those, we have the drones more than 15 in numbers, and they are for the training, for the image sensing, for spraying, all those operations the students are exercising well for their studies, and they are also completed their some of the good achievements which can be shared. So available sprayed drones which we are having with us, they are of DJI Phantom, then parachute type, then fixed wing type, and spraying drones, quadcopters, hexacopters. As this is the part which is very important for the students to know the technical aspects of the drone, how to drive the drone, how to take care of the drones while they are working in the field. Those all the things which are covering with our specified course, which is we having 1 years of professional certificate course, and that certificate course can be joined by any of the science, agricultural sciences, traditional engineering, agriculture engineering, food engineering. All those who are interested to join, they must have their degrees in science specifically. So they can join for the 1 year of course, which is newly introduced. Also, similarly, we have introduced the 1 year course in AgriBoat for studying agricultural robotics and agricultural automated guided vehicles, which are working in the field automation system. The specific applications wise, the drones are need to be also designed. So we are not stopping with the training in amongst the agricultural sciences students, but we are also aiming to make the students learn how to design the drones. So for that, the design and development, we have a CAD/CAM lab. In this CAD/CAM lab, we can use the software such as ANSYS software, SolidWorks softwares, then Nexus softwares. We are having those all softwares to make the students practice all the time when they think of some new design components in the drone. But specifically, the students are having very good kind of outcome as they have started designing the gimbal of the cameras. So gimbal of the cameras, then some attachments for the drones. They are doing their modeling, software modeling, solid modeling. They are doing their analysis, simulation, and finally, once they get the object which is recognized as a best suiting to that drone, they are going to produce it by using 3D printer and applying it for their desired results. So here is the system for which I should say the application in the drones can be one of the new grown up area in which our facilities, as we are using these facilities. So these facilities will be helpful for the students at our level for crop monitoring system. Now, the system that we are studying here in University of Florida for the applications to get the remote sensing for identifying the quantum of the biomass and also to predict the yield in the field, that is going to be help out for the farmers who can see their field and they will let know about their production, how much is going to be yield out. So this is one of the new attraction. This is now I am going to present it for the students and researcher faculty once I get them complete here. So I am very much fortunate to have such a kind of domain where United States of America have different kinds of the application culture and laboratory facilities which we are going to help out, because they are started doing activity here as a drone club, and I was I am the one of the participants with Professor Aditya Singh and his drone club from this University of Florida, which will be extended to Vasantrao Naik Marathwada Agriculture University by the students participation from both the universities. So students will be designing and fabricating at this University of Florida campus for their technical aspects and testing, and the field ground and the performance feedback can be taken back from Vasantrao Naik Marathwada Agriculture University. So all those the drones which we have specifically aiming to make them present before the farming society is the one of the important aspects in digital farming solutions. Agricultural AGV is automated guided vehicle. We have already developed Android-based sprayer of which is 65 liters of capacity with boom lens and a facility of energizing by use of photovoltaic batteries. And also farmers can easily operate it by use of the mobile phone by GPS location. This sprayer can be used in the vegetable crops as well as the small height crops where the device can run and spray it accordingly as the pressure you designate. So there is a camera system on which you can see the location of the device as well. So the cotton picking machine, that is another device which is very much attraction to the farming society with the very much economic cost. We can have the cotton picking process by use of this machine by pneumatic suction pressure method. We have experienced 16 to 20 kg cotton can be collected per hour. So with the shift of day, one operator, maybe a man or woman, can pick up the 160 to 170 kg cotton at field. We got a very good experience in this regard. I can show you the videos. The students are also doing their operations by using different kinds of the sensors as well. So as a the CDKS is a portfolio wherein the students of agronomy, meteorology, they are working and they are having their applications to get this research incorporate in their thesis as well, also to get the outcome for the farming society in terms of the output devices. Professor from IIT Bombay also taking their GPS GIS based trainings, which will be helping the students to get learn of the highest possible tools which can be aiming to make the solutions out with a precise outcome. We are taking the different trainings and we are also interested to make them all involved in the IIT environment. So IIT Kharagpur also has been involved the students and they have taken 1 month's training for the students of agricultural sciences. So there every cycle of the semester period there is one training. We are aiming to make the students aware of those all are updated technologies in IITs. The seed and seedling processing nursery automation is one of the attraction wherein we have a grafting robot. That grafting robot can graft the Solanaceae and Cucurbitaceae family crops. So wherein the rootstock of eggplants, that is a brinjal, and the cyan of tomato, we are used here to get the grafting process done here. So we have this kind of applications, and we are making these all applications to get run of the new technologies to the students as well as the researchers. And once it is developed, the nursery entrepreneurs also can be developed here in the region. So nursery automation have their different attractions to work with the control systems and the control environment as well as the open field system, their related nursery products. So here the seedling, we have a nursery processing automation systems. We are practicing the making the students aware of the different technologies, how it can be developed in the field by use of the cold chain mechanism. Also, we are using the cold van for these plants to reach in different destinations of the university center. We are also having the seed smart portable machinery division, and this division is very much helpful. This division is going to make the students developing different kinds of small portable machinery which are having a smart mechanism as a use of the sensors, use of automation system. We developed a scissor lift. We developed the bike in collaboration with Aryan Tech Industry. We are also associated with different industries as well as a craftsman. So Vishwadeep Udyog from Palam, Shirale, he is one of the excellent smart entrepreneur. We have trained him, and also we have the other craftsmen from this region, those who are coming up to us and getting this technology developed and make them reach to the farmer's hand. So use of this technology and smart portable machinery is one of the new attraction for the economic aspects. The customers should offer the technology also as well. So from that point of view, we are very much keen interested to develop those harvesting technologies, harvesting mechanism technologies, and also the different sowing and interculture operation technologies. In food processing automation center, we have attraction of the 3D food printer. As a 3D food printer, which is going to help the women's farmer at their home, they can have their business and well-established kind of such a product which are outcome and getting help to reach into the customer's hand. So many of them, nowadays, as the attraction of this center is, we have developed a mobile-based operative, this 3D food extrusion printer, which is the students, we are making them aware of how the technology is to be developed. So we have initiated collaboration activities with Cibros from Aurangabad. They have initiated and started working with us. So this technology fabrication as a facility we are creating in Cibros, and we are having those all the standard extruded plate designs by the students. So number of products as the students brainstorming is extended to the good state of art, that will be a new attraction. We have developed a disinfection box also machine, and those disinfection box will be very much in the commercial economic rate in the market, available for the society, farming society specifically. Then we have the mechatronics lab, which is going to help the students for their applications, how do they can operate the different kinds of electronic mechanism. So that is why the instrumentation cell is one of the interesting portfolio, where from the different devices, sensors, and the students' attraction is to get learn by self-learn kit, which is introduced by the different industries. And we are having this CNC SMS technology, CMS technologies, CNC technologies, and we are using them to get the operations learned by the students at their own practical laboratory level. So they can put their artificial intelligence programming, logical inputs to make the study of IoT tool development, and these automation technologies going to help them for their future career wherever they apply for the job. So students are created nozzles, then gimbals, then different kinds of irrigation components, smart portable irrigation system component devices, then robotic arm devices. So they have also designed and developed the robotic arm for attachments on the automated devices. Students are taking their field practices on the field, and they're doing their mapping. They are going to get the knowledge of how the drone based aerial observatory looks, and different camera with their applications can help them to determine the health condition of the crop, as well as the vegetation status of the crop in the field. So this is going to make the part of a new area and venture for the upcoming students who like to learn the digital technologies at this center. ANSYS is one of the great platform for the students to have a detailed depth of knowledge in getting up how to design and develop the different machine component models, and then get them analyzed by use of simulation process, using solid modeling, geometric modeling, using finite element analysis, using their simulation by different field ground applicant parameters, and they can learn how to design the best components for the agricultural applications in machinery and the automated system, wherever the components are need to be observed and carefully designed. So field demonstration, then training on the sensors ground, the students are nowadays practicing. So I like to just show you the machines that are developed, can be operated by man or woman for cotton picking process. So for a day, 150 to 170 approximately the cotton can be picked up in the drum, and that will be helpful to work as a quantum of the three labors efforts by using this machine. This machine is working on the basis of 48 watt heavy solar panels. We have a pneumatic suction RPM machine, I mean the motor, which is taking up the power from solar, which is stored in the photovoltaic system. So I like to mention it over here that the development of such a product which is helpful to the farmer is the basic aim, and we're definitely going to create such a human resource by training the students, and we are very much interested to see the interest of the region and in our nation to get the students learn. So robotic drone, robotic applications as well as the problem which is we can solve by economic way by developing small machinery, and whenever there is a big field farm, we can have a robotic applications which will justify the cost of the application device. So you can see speedy operation. Pick up. The another device uh, uh, that is developed in the uh, University of our Vasanthav Naik Marathwada Agriculture University is the remote control based paper pot chain mechanism based this transplanter. This works on the photovoltaic battery and the solar systems. It transplants to 65 plants per minute, and this is we are going to develop it by using the automation system mechanism. We can use the robotic system, which will be helpful for the vegetable growers, cultivators who are in need of such a kind of mechanism as a labor scarcity. The small devices which we are introducing to the farmers that are very much interesting. So our students are also asked to get the different kinds of component, learn how to get printouts as a component and their use in the field ground. Whenever you require such a kind of device, they must go for software and hardware learning both together, and their application which is making up ground to develop such a facility by their small projects will definitely make the empanelment of the followers and then subsequent chain which will be one of the attraction from this center. Where students are started developing different models. As I'm just showing here, they are having their different models. They are developing not only the components of the machines, but they are also making them all with their structural analysis, cumulative fluid dynamics analysis, and those such components which are developed, and finally they get print out and then checked up. So students can easily loop up in getting up their patents. Once they start imagining, they will get it draw as an imaginary drawing, and then after that they will get print out and test it on the field ground which is validated, and thereafter the results will come out, and once it is finally accepted, that can be patented. So patent cycle for the researcher is very easier if they once started developing with their own brainstorming and getting them out to be as outcome, a good outcome and result for the field application. So we have the results from the students. They are doing their applications. They are submitted. They are publishing papers also for this, and their researchers practices whatever they are noted down from the different disciplines. As I'm presenting, just to make this as of outcome from the center, which will be definitely going to attract, and the students from different disciplines, they are get interdisciplinary involvement, and also faculty will get interdisciplinary involvement from different departments, and from this different department those students who are getting their outcome will be extending their future studies in different locations as well. So I'm here just to make the presentation of the center with a very short time, as I'm out I'm at a remote location, and I'm just now not able to if connect with this uh, the network system. So I may be able to at least have some dialogue and discussion at the time of meeting. So I just thanks to uh, thanks to the all of those resourcing strength and patrons of this project, and also I am very much thankful to the all NAHEP team member from our center, specifically core team members, associate team members. They are taking efforts as well, and on the battleground, our great soldier is none other than our NAHEP staff and researcher students. Those who are working with this and we are getting experience and exposure from different levels, from different countries. This is we are finding that the since last 3 years of our activities, which are not stopped even in the COVID situation. We are continuously working, and that is why the center is established. We can see that all the developments from our portal, that is VNMKV.org.in or https://NAHEP.vnmkv.org.in. I'm really inspired and excited to make the University of Putra team for involving, because I visited University of Putra in 2018. That time I visited to the dean of the university. Then some of the farm machinery professors, and I'm really thankful to the university president, who is who is initiating this kind of activity along with their team. So we have a lot of things to do, but in short, nutshell, I should say the digital farming related solutions for the students from this campus will make their entitlement and their problems as a individual problems during their training, and they will explore their outcomes before, after completion of this training. They will explore their outcomes to this university, and it will be a nice journey between University of Putra, Malaysia, and Vasantrao Naik Marathwada Agriculture University. So thanks one and all. I'll get back for the discussion.